Time to get acquainted with RIP now and some not so complex commands, but definitely one squirrely default we got to be aware of. We'll see that right away. Now, I have checked connectivity over the 172.12.123.0/24 network. One can ping 2, etc., etc. And the loopbacks are present on 2 and 3, but of course they can't be pinged because right now we don't have any static routes, we don't have anything going on as far as the routing protocol, but that is about to change. I want to show you one thing before we start our config here on router 1, and that's that I ran a command called show IP protocols. I believe we've seen that before, but what I really wanted to point out to you is that every once in a while you're going to run a show command and it's going to skip a line, as you can see here, and then just go right back to the cursor. And I just want to let you know that doesn't mean that something is wrong on the router, but it does mean that there's nothing to show you. And this is common with 99% of the show commands that you run. You're not even going to see little headers or a table or anything that's empty. You're just not going to see anything. So don't let that freak you out. It just means that right now we don't have any protocols running. We are about to change that, and I'm going to start with conft here and router rip. And unlike other routing protocols that you'll study later, there's nothing else outside of the router rip command when you want to start your rip config. You don't have any numbers or any values, anything like that. As you can see with iOS help here, we literally don't have anything else we can do here except hit enter. So we've dropped down, and I'm going to use the network command first to enable RIP on any interfaces on the 172.12.123.0/24 network. And we're going to do that just like this. You just put the network number here. Now with RIP, you can put the major network number if you wanted to, because this is probably going to show up a little bit differently in the config. We'll take a look here in just a moment. And I don't want that to freak you out either. I want you to see it here. And what you'll see also is that we have no options with this network command, and in later protocols that you study, EIGRP and OSPF in particular, you are definitely going to have some options there. So as you can see, RIP's pretty darn simple to run. And let's do a quick show run. And let's take a look at our RIP config to date. And you can see that you've got 172.12.0.0 here, even though I entered 172.12.123.0. That's always going to go back to the major network number. And since this is a Class B network, that major network number would be 172.12.0.0. So don't let that mess you up either. So we've got that rocking and rolling. And now let's run show IP protocols at this point. Now we haven't gone to the other two routers yet, but we do have something running here. And this is a great command to run over and over and over in lab environments. If you have one in a production network, it gives you a wealth of information. And going from top to bottom, though, you can see on that third line, third line after this line, routing protocol is RIP. We've got some filter list information here first, and we don't have any filter set, so it's telling us not set. But here's one reason we really don't like RIP. You know, it's sending that full update table every 30 seconds. There's just not something we really need. And we've got our next due in 13 seconds, of course, when I ran this command. Don't concern yourself with these other timers. We've got redistributing RIP. It's going to say that even though we haven't configured any route redistribution. It's always going to name the protocol right there. And default version control. Here's that oddity, that squirrely default I want to tell you about. You know, we've got two versions of RIP. We know that. We know the similarities. We know the differences. And you would think that when you run RIP, you know, it would either be running all version 1 as far as sending and receiving, all version 2 as far as sending or receiving, or sending and receiving both. But as you can see, that's not the case. By default, a RIP-enabled interface will accept either version and update in either version 1 or version 2 format, but it's only going to send version 1 updates. Pretty odd. And the thing is, we don't want that, because we know the deficiencies, if you will, with RIP version 1. We want the subnet information. We want all those great things that come with RIP version 2. So what we want to do is hard code the router so it will send version 2 and accept version 2, and then that's it. And you'll see here it's going to give you this information on a per interface level. And right now we only have one interface running RIP, so it's saying, hey, you're sending version 1 updates, but you're accepting versions 1 and 2. Note this sentence carefully. We're going to come back to this in a lab in this section. Automatic network summarization is in effect. We're going to see if that's good or bad a little bit later on. Maximum path 4, RIP performs equal path load, equal cost load sharing. So if there were more than one path to get to a destination and they had the exact same metric, and we know the metric with RIP is hop count, then it would start sharing the load over those paths. And by default, it's going to do up to 4 paths by default. So routing for networks, 172.12.0.0, we got that. And this is interesting. Routing information sources, and it would look like we don't have any. And right now we don't have any because router 1's the only router that we've configured anything on. So we certainly hope as we add to that we will start seeing some routing information sources, namely routers 2 and 3. Distance, default is 120. That's definitely not a metric. It's definitely not hop count. So what is that? We're coming back to that in a later lab in this section as well. So a lot of previews here, but I really want you to get familiar with this command. And as you progress in your studies, you start using OSPF, you start using EIGRP, always come back to this command because it just gives you a tremendous amount of information. So before we go to routers 2 and 3, we're going to hard code router 1 to only send version 2 updates and only accept version 2 updates. And we do that actually one of 2 ways. I want to show you both ways. Rarely you'll see this, but you can do it at the interface level. And what I'll do is do a serial 1.0, and I believe it's IP RIP. Yeah, IP RIP, and then you see the options here for receive and send. So if you really want to get particular on multiple interfaces on a router and you want to send and accept version 1 on one interface, send and accept version 2 on another, you can do that. And you would just do send version and then 1 or 2. You would have the option of doing both. So you can do it on a per interface level. What I recommend you do, and what you're going to see most of the time, is that you just do it, period. You tell the protocol, you tell RIP, hey, wherever you're running, I want you to run all version 1 or run all version 2. And you do that under router RIP, and the command is version. Let's try that one, and you can see RIP version 1 or 2. And you'll notice this command does not give you the option to put 1 and 2. You got to choose one or the other. So we're just going to go with version 2, and we will verify that really quickly. And you can see that default version control has been changed. We changed the default to send version 2, receive version 2. We also see the interface is sending and receiving version 2, and we're all set there. So when we come back, we'll zip down to routers 2 and 3 at the beginning of the next video, configure that, and we'll march on from there.